So welcome back. So I think we are here in the process control instruments class. So let's see. See first, I'm just repeating the questions. The question is there are two steams, steam one and steam two is going inside the tank. Okay, and this is the mixing T. One of the control man or one of the operator at 3 p.m. sharp, he misreads the flow of this flow stream. So what he done? He changes the shifted the switch of the flow and then shifted to 10 liter per minute to I think 20 liter per minute. Yes, and 20 liter per minute to 10 liter per minute. And after 1 hour or after half an hour, the main supervisor will comes and check out the problem. What is the source of that problem? Okay, and now he want to correct this problem. First, he want to analyze what happens in last half an hour. So for that purpose, he has model. The solution is he model the problem. So how that he model? So model the mixing tea and blending tank using unsteady steady state mass. मैंने आपको बताया था. I have told you all already. There are two types of generally model occurred in the process industries. First is the steady state model, and the second one is the unsteady state model, right? So what is the difference between them? I will differentiate this two models later on. So first, in the C. So what happens? C shift changes and the unfortunately error by new operator. Okay. So a balance. Now what we are doing, what we are trying to do. Just we are writing the component balance. There are three types of balance equation based on the mass conservation, based on the conservation law. We are writing inside. We are using in the process industries. Okay. So what are that balances? First is the mass balances. There's a mass transfer, you can say. Second is the component balance. It is a one type of, again, this is a mass balance. And third one is the energy, or you can say the heat balance or energy balance. Is it clear? So mass transfer, component transfer, and the energy transfer. Now what we are doing, you know, the concentration what we are entered at the steam 1 is the 1 gram per liter. However, in the second case, it is a 4 gram per liter. Okay. So now what we are doing, we are just try to give the component balance. Okay. So what is the component A balance around mixing T? So what is the component balance? What we will do? Whatever it is entering from side 1 plus side 2 is equal to side 3. Yes or no? Side 1, steam 1 plus steam 2 equal to steam 3. So just we are tried here. So V1 into CA1. So what is CA1? CA1 is the concentration. V1 is the flow. Okay. So you can say this is a V1 is represented in the terms of liter per minute. However, the concentration is given in the gram per liter. So overall, if you see the concentration, you can write the concentration balance equation with the help in the unit of gram per minute. Yes or no? Gram per minute. Whatever the entering the concentration inside the stream 1 plus stream 2 equal to the stream 3. Okay. A stream 1 plus stream 2. Okay. A and whatever this the plus mixing T is here, right? So this will add up. तो क्या होगा यहाँ पे ग्राम पर लीटर में आ रहा है, ग्राम पर लीटर में यहाँ से भी आ रहा है और ग्राम पर लीटर में ही यहाँ से निकलेगा, ग्राम पर मिनट में, सॉरी, ग्राम पर मिनट में. Okay, this is a concentration balance. Is there any problem?
No, sir.
No. Okay, so I think it is clear. So that's why just we have multiplied the velocity in volumetric flow rate and the concentration. Okay, so V1 CA1 for the steam 1, V2 CA2 for the steam 2 equal to the what? V3 CA3. Okay, V3 CA3, right? So this is the component balance, simple. you can calculate, you can put the value 10 liter per minute into 1 gram per minute, है ना? This is the V2 is a 20 liter per minute. This is before the steady state, right? Before changing, this was the condition. It was the condition, right? 4 gram per liter, 30 liter per minute means यहाँ से देख सकते हैं आप 30 liter per minute, but concentration was not mentioned here. So we calculated the concentration here. 3 gram per liter, 3 gram per liter आ रहा था. 3 gram per liter initially when it was the steady state, then it was the 3 gram per liter. However, after the changing, after 30 minutes, after the 30 minutes, 30 minutes क्या हो गया? 20 10 को आपने क्या कर दिया? 10 is changed to the 20 liter per minute, right? 20 liter per minute, and this is changed to the 20 liter per minute. Okay, so now see, this is changed to 20 liter per minute, this is changed to 10 liter per minute, and calculate again the concentration. So concentration becomes now 2 gram per liter. So what is the result? What is the result, Nate? It means initially it was when there is no disturbance was there, when no shifting was there, then the concentration after the mixing was 3 gram per liter. However, when you shift the flow rate of to steam, then now the concentration, the resultant concentration is 2 gram per liter. So it was a change. So 3 gram से 2 ग्राम लीटर पर मिनट में जाने पे ये डिस्टर्बेंस आपको मिलेगा, इस तरह का आपको मिलेगा, राइट? सो what is the result? The result is, so the net result of the operator error is to decrease the feed concentration to heating vessel. तो हमें जितना चाहिए था इसके अंदर जो इन होने वाला था, पहले 3 ग्राम पर लीटर पे इन हो रहा था, now it is in the under 2 gram per liter, right? So 2 gram per liter पे हो गया, clear? So now it is apparent that the exit concentration of the heating vessel will eventually fall from 3 gram to 2 gram per liter, right? 3 gram to 2 gram per liter. If the process is left in the current configuration for so long enough time, so what is the situation? The question is again, if we remain this process, then what happened? What happened? See, now we are changing the concentration from 3 gram per liter to 2 gram per liter. After this is a 3 o'clock and this is a 30-minute duration. Okay, 30-minute duration. Okay, so 3 PM पे आपने कुछ इस तरीके का आपने चेंज किया था और चेंज होने के बाद कुछ इस तरीके का आया, राइट? सॉरी, दिस इज नॉट 30 मिनट, यहाँ से पहले से चला रहा था 3 ग्राम पर लीटर पे. यू हैव शिफ्ट द स्ट्रीम एट दिस पॉइंट, है ना? और उसके बाद ये आपका 2 ग्राम पर लीटर पे शिफ्ट हो गया. नाउ व्हाट वी एनालाइज, व्हाट हैपेंड, क्या ये 3 ग्राम पर लीटर से 2 ग्राम पर लीटर क्या तुरंत हो जाएगा? क्या ये कुछ इस तरीके का तुरंत सीन दिखाने लगेगा? 3 ग्राम टू पर लीटर 3 ग्राम इतना 3 PM पे चेंज हो जाएगा, और इट विल टेक सम ट्रांजिएंट? व्हाट इज योर ओपिनियन? क्या ये ऐसे चलेगा या सम ट्रांजिएंट विल बी देयर?
Some transient will be there.
Some transient will be there. So what is that transient? What is, as a control engineer, what is your target? Your target is to reduce this transients or to remove this transient? Yes or no?
Yes, sir.
So
Yes, sir.
now we seeing what happens here. So for the transient purpose, okay, for the transient purpose, when we see when we tell the transient word, it means we are now writing the d by dt term. D by dt means we are now changing, accumulation term will be always there, right? So for that purpose we are now, so this is the steady state equation. Remember, this is the steady state equation. A steady state equation, steady state, there is no changing of time, the steady state equation. However, this equation is the unsteady state equation. Unsteady state equation. Why? Because here the concentration, the component is changing with reference to the time, right? Okay, so now whatever the stream is going entered into the tank, this मतलब आपको समझना है, फिर से मैं आपको बता रहा हूँ, किसी भी आपको जब भी आपको मॉडल करना हो तो रिमेंबर ऑलवेज व्हेन, खासकर अनस्टेडी स्टेट, एट द अनस्टेडी स्टेट, इन माइनस आउट, इन माइनस आउट इक्वल्स टू, इन इक्वल टू व्हाट? इन जो जाएगा, whatever the liquor or concentration is entering inside the tank is equal to sum out plus whatever the accumulated amount. Okay, so out plus accumulation. You can write yes or no. Out plus accumulation. Out, this one is out, and this is some accumulated material. So when we add this thing equal to the in. So this is a fundamental. We
Sir,
will
what
use
is accumulation?
what is accumulation? Sorry,
Yes, sir.
accumulation
That part.
represents, yes, accumulation represent whatever the amount changing, yeah, whatever the mass changing here, you can say, Anna, with reference to time. Let's say d by dt of whatever the mass is here, whatever the heat is there inside this tank. ठीक है, तो टाइम के साथ वो कितना वहां पर है, that is your equal to the, suppose that we are representing the concentration, we are representing the concentration, whatever the concentration is changing with the time, क्या होगा वो concentration कितना accumulate कर रहा है with the time, तो उसको तो यही रिप्रेजेंट करेंगे ना, VSC, या सुनो,
Okay, sir.
समझ में आया या नहीं आया?
Yes, sir.
Okay, so rate of A into the heating vessel, whatever there is entry, whatever is out, rate of A leaving the heating vessel in gram per minute, equal to the accumulation, whatever the accumulation is inside the tank, right? तो क्या किया हमने, so for that purpose just we are writing VCA3, V3CA3 minus V3CA equal to d by dt of VCA, right? तो हमने ये लिख दिया, कोई प्रॉब्लम, any question? CA represent what? CA represent the obtained concentration of that liquor, product side, है ना? So now just defined by the V3, है ना? V3 से आपने what we have done, we have defined this. So ये हो गया आपका क्या, V3, when you arrange this equation, so you can write like this, just to define V3, 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 right? So it will give what? CA3 minus of CA is equals to V by V3 d by dt of CA. Okay, d by dt of CA. Cookie concentration is changing, right? So this is the final equation. Okay, now see, this is the final equation, and this equation tells us regarding the time constant. So when you heard the first order system in the control system, so then that control system represents what? Anyone can tell what is the model equation of that? Yes, this is the tau. Tau. What is the transfer function for this? Tau s plus 1 upon k. Yes or no? Yes
Yes,
or
sir.
no? So this is nothing but the first order transfer function. This represents tau. V upon V3 represents the tau, and d by dt of Ca plus Ca3 is the first order differential equation. Now try to analyze the equation. That equation is, now we are writing here V by V3 dCA by dt, okay, plus Ca equals to Ca3. Sorry, Ca equal to Ca3. Okay, so now V by V3, just the values given, just to calculate this one, Ca is this one, Ca3 is already known, यहाँ से हमने क्या किया, and this is the initial condition. Initial condition means at before the disturbance. Before disturbance, this was 3 gram per liter, okay, because we need the, when we solve this equation, we need the first initial value, okay, because this is a differential equation, first order differential equation, okay. So the initial value, with the help of initial value, just to calculate this equation, okay. So when you solve, or either with the help of Laplace equation, you can also solve. Yes or no? Yes or no? Tell me.
Yes,
5s
sir.
into CAS माइनस वाट एवर क्या हो जाएगा, CA0, है ना, माइनस प्लस C अपॉन 2s, है ना, तो इसको सॉल्व कर लो, है ना, इसको सॉल्व करने के बाद, व्हाट विल डू, प्लस CA, है ना, और इसके बाद क्या हो जाएगा आपका 2/s, इसको सॉल्व करने के बाद ये फिर से उसको टाइम इनवर्स में निकाल लो, लाप्लास इनवर्स में, है ना. Then when you solve, then you got this such type of equation. After CA is equals to 2 plus e to the direct. You can also solve with the help of direct differential equation, right? So it is your choice. Simple. How can you solve with the help of the differential equation? Simple. dCA is the first order equation just to change the dt. Okay, and 2 माइनस ये क्या हो जाएगा 3, और इसको करके आप 2 माइनस ये करके आप इसको कर लो यहाँ से, ठीक है. तो this is the exponentially decreasing 2 plus e to the power minus t by 5. E to the power minus t by 5 represents the exponential decreased equation. So the nature of this means the nature of the decrement from 3 to 2 is like this one. Okay, 3, this one 3, this is the 2, and this is the, this will go like this. Okay, this is the 2, this is the 3. So this is the ultimate equation. Ultimate, you can say the behavior. ठीक है, any problem, any question? If you have any question, you may ask, otherwise I will proceed. Is it okay? Is it okay? Yes or no?
Yes, sir.
Now, the second problem, the same problem is this one. Now, just we are introducing the temperature term. Okay. So this is example of the chemical mixing process flow diagram showing the initial temperature also now. Okay, the temperature of that liquor, whatever the intake from stream 1 is the 25 degrees Celsius, and the temperature of the liquor entering from the stream 2 is the 55 degrees Celsius. Flow rate was the same, 10 liter per minute in 20 liter per minute initially. At 3 o'clock it was changed, it was shifted, it was shifted to 20 liter per minute, and it is shifted to the 10 liter per minute. Now we want to analyze how the temperature is going to change. How the temperature is going to change. Okay, so this is the Ca3. Now we have already calculated Ca3 is 3 gram per liter, V3 30 liter per minute, 20 plus 10 initially, and T3 we don't know. However, we have the 20 final we want T 80 degrees Celsius. The desired temperature of the product is 80 degrees Celsius. Okay, so it is the statement what I have told you. Stream 1 at 25 degrees mixes with steam 2 at 45 degrees Celsius, producing steam 3, the feed to the heating vessel. Now second statement is the heater adds some energy, regulator adds some energy to vessel to bring the outlet steam to 80 degrees Celsius. Whatever the temperature desired is provided by, if any temperature is less, then it is provided by some heat, this heater, to maintain the product temperature 80 degrees Celsius. Okay, so before we look at the effect of the disturbance caused by the operator, it is necessary to determine the steady state process condition prior to upset. Okay, so पहले तो हमें transient को check करने से पहले again we have to check the steady state process parameters. Okay, so how the steady state equation will be written? पहले हमने क्या लिखा था component balance के लिए. Now we are writing for the temperature, for the heating. Okay, heating के लिए लिखेंगे. क्या लिखेंगे? Heating के लिए. Now how the heating will be written? क्योंकि T3 आपको पता नहीं है. We don't know how what amount of T3 is going to enter inside this tank. So first we have to determine the temperature T3. Okay, so rate of enthalpy into the mixing tank with steam 1. ठीक है, तो what is the heat? तो अब ये इसको कैसे कैलकुलेट करेंगे जी? Anyone can tell me? Anyone can tell me? बताओ. What is this equation? Please. Please. बोलो. यस, बोल नहीं रहे सब. What is density? What is density? Density is mass upon volume. Yes or no? So mass is represented in the kg per meter cube. What is V1? बोलता ही नहीं. What is V1? What is V1?
Sir, V1
Huh?
10 liter per minute.
V1 is the
Volume
volumetric
flow
flow
rate.
rate. बोलो, है ना?
हाँ जी, हाँ जी.
V1 is the volumetric flow rate, and that is the liter per minute. Yes or no?
Yes sir.
Liter per minute. Liter per minute में है वो.
हाँ जी.
बाकी लोग सुन भी रहे हैं या नहीं? इससे तो वेरी प्रॉब्लम हो जाएगा, तुम लोगों को बता रहा हूँ. ध्यान समझो. सो V, मैंने बताया डेंसिटी इज अ मास अपॉन वॉल्यूम, है ना? इट इज अ वॉल्यूमेट्रिक फ्लो रेट, दैट इज अ मीटर क्यूब पर सेकेंड और द लीटर पर मिनट, है ना? Liter per minute. This is a mass. Mass means kg upon volume. Volume is again the liter or the meter cube. What is CP? What is CP? CP is the
Gram per liter.
huh? Sorry. What is CP? This is the enthalpy. Yes or no? Specific heat है ना? बताओ भाई. What is the specific? बताओ. Specific heat की यूनिट क्या है? What is this? This is the calorie per gram degree Celsius. Calorie per gram degree Celsius. Right. So with the, and what is the temperature? Temperature is in the degree Celsius. देखो ultimately क्या करना है? What we are trying to do? We are writing the heat equation, heat transfer equation. So for that purpose, for the heat transfer function, you can write just balance down. क्या हो जाएगा? ये क्या बनेगा आपको? This is in the gram. So gram per liter into liter per minute into calorie per gram degree Celsius into degree Celsius. यही तो है. This is the density. This is the volumetric flow rate, and this one is the CP, and this one is the temperature. When you multiply all these things, what you will get? This is the gram, this is the liter, and degree Celsius. Then it will again calorie per minute. What is the calorie per minute? Represent. What is the calorie per minute? Calorie per minute क्या कह रहा है? What is the meaning of the calorie per minute? Calorie per minute means some energy is there that is changing with the respect to time. Yes or no? Calorie is changing, the energy is changing with respect to time. So that's why we have written this equation. So remember, if we have to maintain joule per minute or joule per second is the unit of the energy transfer, and again you can just calories also. You can here the gram, here the liter, or you can also use the SI unit, that is kg per meter cube per second, है ना? And the joule per kg in degree Celsius. Okay, so with the help of also you get also joule per second only. This is the heat transfer equation. Right? So we have just written the heat transfer balance equation for the entering 1 plus entering 2 equal to entering 3. This is the first, this is the second plus 3. Okay. So similarly for now, the question is why we have written the T1. This is the T1. Is it okay? But why we have written minus reference sign? T1 minus T reference. Anyone can tell me? Okay, this is the heat transfer equation, but why we have written the delta T into MCP delta T, you know very well, Hana? This equation is very famous. MCP delta T. This is the heat transfer equation. And what is the mass? So mass, what is the mass? How the mass will be calculated? When the density in the volumetric flow rate will multiply, it will automatically give the mass. Yes or no?
Yes.
When the density, that is the kg, mass upon volume, है ना? Mass upon volume, and this is the volumetric flow rate, this is a meter cube per second or whatever. तो उसको क्या मिलेगा? ये मिलेगा. Okay. अब बताओ मुझे why the reference temperature is given? Why the reference temperature is given? Why the T reference is given? Anyone? T1 minus T reference, T2 minus T reference, T3 minus T reference. For all, this equation has been written. Anyone? No. No answer. Okay. So try to search this answer. I will tell you in the next second class. Okay. First, it is your task to search this answer of this question. Why we have written T reference? T reference आपके लिए मैं छोड़ देता हूँ. इसका आपका काम है इसको ढूंढना. वो कल मुझे बताएं. अगर नहीं आएगा तो बताऊंगा. Okay. So this is the equation. Now we can solve this equation. Rho cancel out each other. Cp for the dense specific heat is equal to all. And entering 1 entering 2 same लिखा. अब इसको तो you can calculate like the V1 plus V2 T reference. यहाँ से आप calculate किया T reference is also out. Okay. So it simply gives the T3. You can calculate the T3 with the help of VT1 plus VT2 VT3. Okay. So T3 is 45 degrees Celsius. It means the temperature of the inlet liquor, whatever the liquor is entering inside the tank, the temperature is the 45 degrees Celsius. Okay. Now, so steady state inlet temperature to the heating is 45 degrees Celsius. Now, what we have done, what we are doing, the operator is doing shifting the flow rate. With the help of the shifting the flow rate, now we have to analyze what happens. We have 5 minutes. Okay. So, अब इसमें हमको लिखना है तो क्या लिखेंगे देखिए कुछ इन हो रहा है दिस इज द इन दिस इज द आउट इन आउट ओके सो देखिए दिस इज द इन रेट ऑफ एंथैल्पी एट द स्टेडी स्टेट इक्वेशन इज रिटन दिस इज द स्टेडी स्टेट डिटरमिन द स्टेडी स्टेट हीट इनपुट रिक्वायर्ड कितना हीट चाहिए इसको 80 डिग्री बनाने के लिए 80 डिग्री सेल्सियस बनाने के लिए 80 डिग्री सेल्सियस बनाने के लिए हीटर को कितना टेम्परेचर देना पड़ेगा क्योंकि 45 डिग्री सेल्सियस इन हो रहा है यस और नो सो स्टेडी स्टेट इक्वेशन वी हैव रिटन फॉर द इन प्लस इन इक्वल टू आउट सो अगेन वी हैव रिटन रो v3 cp t3 minus t reference plus q is what this q is this one is the q heat is entering from the heater okay and the equation for the product side. So you can calculate the key value. You can calculate the Q value. If this value is known, this value is known. Based on this, you can calculate the Q value. Okay. Q value is 73.2 kilowatt. इतना आपको और calorie per minute, whatever. इसको हमने this is converted into the watt. So इतना Q is required. 73.2 kilowatt is amount required to obtain the temperature of 80 degrees Celsius of the product side on the product side right तो ये तो हमारा हो गया now तो इतना आपको हिट देना पड़ेगा शुरुआत में इनिशियली अब करते हैं कि आफ्टर द चेंज व्हाट हैपेंड व्हेन the change was occurred this is the flow of the first liquor first steam it changed to 10 to 20 and 10 to 10 20 to 10 right 20 to 10 हमने यहाँ कर दिया 10 से 20 यहाँ कर दिया then the temperature will come that the T3 will come 35 degrees Celsius 35 degrees Celsius means initially we have 45 degrees Celsius but now we have 35 degrees Celsius ठीक है जी 35 degrees Celsius हो रहा है तो पहले तो यहाँ पे कुछ ट्रांजिएंट होगा और उसके बाद 80 डिग्री से कैसे होगा अब उसको देखेंगे ये इनपुट आपका 73.2 किलोवाट का आपको चाहिए यहाँ से so now you can see for the transient purpose again we have to write the unsteady state equation and unsteady state equation is written how so for this one for this purpose this is the in this is the in this is the minus out this is the first in this is the second in this is the first out and some value is accumulated here some heat is accumulated here that is written in the term of this one in from the first side minus out okay plus some heat and some accumulation is it clear okay so now just solve the equation v by v3 again the tau d by dt यहाँ the temperature balance we have written okay just to solve this equation with the help of the Laplace transform or you can say the temperature for differential equation Then you got t is equals to 70 plus 10 e to the power minus t by 5. T is equals to 70 plus 10 e to the power minus t by 5. And this is the profile. This is the simple profile. So you can see here. So now I think the problem is clear. If you have any query, just to go through the Kafner book, you can understand it. Yes. So just I am stopping here.